Hey everyone, welcome back to The Explainer. Today, we're hitting a massive milestone, day 12 of our code review journey. And what's on the menu? Authentication. Let's dive right into the source materials and get this show on the road.
Okay, so day 12, authentication. This is literally the absolute core of your app's security, right? It's the front door. But here's the thing, and this is exactly why we're dedicating a whole day to a manual code review of this system. Automated vulnerability scanners are, well, they're notoriously bad at catching logical authentication flaws. I mean, sure, a scanner might flag an outdated library, but is it going to notice that a developer built a totally flawed password reset flow? Or maybe bypassed a critical authorization check? No way. That is exactly where human intuition comes in. We really need to evaluate the logic to make sure an attacker can't just waltz in and bypass the whole system.
So, looking at our source material, we've got a strict pre-flight checklist for today. We're verifying 4 main pillars: password hashing, token handling, session management, and protected routes. That's the game plan. Let's break down exactly what we're hunting for in each one, starting with how user credentials are put in the vault. All right, first up, password hashing. When we evaluate this, we aren't just checking that a hash, exists. We're really interrogating the implementation details. You got to look at the exact algorithm being used. Are they using something modern and memory hard, like Argon 2 or bcrypt? Because fun fact, a shocking number of enterprise apps actually still fall back on ancient stuff like MD5 or SHA-1. Seriously, don't let yours be one of them. Beyond the algorithm, you need to scrutinize the work factors or the cost rounds. They have to be set high enough to stop a brute force attack in its tracks, but not so high that they create a denial of service bottleneck on your own servers. It's a balancing act. Oh, and critically, check those salts. Are they cryptographically random and unique per user? Or did someone just hard-code a master salt into the config files? Yikes! If the implementation doesn't meet these standards, the review absolutely fails. Next on the list, once those credentials actually check out, the system usually issues a token. And let me tell you, when you're reviewing token handling, you kinda need to be meticulously paranoid. If the app uses JSON Web Tokens, JWTs, you've got to check those signing algorithms. A classic, honestly severe vulnerability is failing to enforce the algorithm type. This basically allows an attacker to pass a token with the none algorithm and completely bypass signature verification. Crazy, right? You also want to verify the claims. Make sure those expiration times, the EXP claims, are reasonably short. And you've got to look super closely at the client-side storage implementation. If tokens are just being dumped straight into local browser storage, they are sitting ducks for cross-site scripting or XSS attacks. You need to ensure there's a rock-solid strategy in place to keep those tokens out of the hands of malicious scripts.
Now, for stateful applications, tracking that authenticated state introduces a whole other set of attack vectors. Reviewing session management means really digging into how the session cookies are configured. It's not enough to just say, okay, we set a cookie. You have to explicitly verify the HTTP-only flag is there to block JavaScript access. You need the secure flag to ensure it's only transmitted over HTTPS. And don't forget the same site attribute to mitigate cross-site request forgery. Plus, you've got to trace the session invalidation logic. Think about it. Does the session truly die on the server when a user hits logout? Or is the app just lazily deleting the cookie on the client side? What happens if an admin revokes a user's access? You absolutely must confirm that the server aggressively, and I mean immediately, invalidates that active session.
Moving on to our final check, protected routes. Look, all of this robust credential and token management, it's entirely useless if the application's actual endpoints aren't explicitly locked down. A super common pitfall here is developers relying on client-side obfuscation. Hiding a button in the UI does literally nothing if the underlying API endpoint is still wide open to unauthenticated requests. You really need to verify that authentication middleware is applied systematically. Usually that means it's applied globally with explicit exceptions for public routes, rather than just crossing your fingers and hoping developers remember to tag every single new sensitive endpoint. You're hunting for edge cases here, maybe an obscure analytics endpoint, or an old version of the API. Make sure they are subjected to the exact same rigorous server-side authorization checks as the main dashboard. No exceptions.
All right, so we've established our theoretical framework and the specific vulnerabilities we're hunting down across those 4 pillars. But as we know, knowing the theory is only half the battle. Now it's time to pivot right into the hands-on execution phase for day 12. We are moving out of the high-level concepts and stepping straight into the trenches to apply this to a real-world scenario.
For your practice assignment, you're taking these 4 checks and actively applying them to review a real login system. Consider this your mission briefing. Don't just skim the pull requests or look for simple syntax errors. Here's a pro tip for your review. Trace the logic flow chronologically. Start from the initial HTTP request, follow it all the way down to the database query, and then follow it back. You're hunting for those exact edge cases we just talked about, the missing validation logic, a dangerously configured cookie, or some forgotten route that leaves the whole app wide open. You are actively searching for reasons to reject the code until it truly proves its resilience. So, as we wrap up today's explainer, I want to leave you with a real challenge for your Day 12 assignment. Don't just verify that the login system works seamlessly for the good guys. I want you to prove that it absolutely breaks predictably and securely for the bad guys. Ask yourself, is your login system actually secure, or are your protected routes left wide open? Have fun reviewing, keep building those secure defenses, and I'll catch you in the next explainer.